everyone, I'm Shiny. Today I'm going to present the MobileNet V2 model works for detecting diseases on plant leaves. In this, we define the MobileNet model. I load the MobileNet V2 without the top layers and freeze its weight to preserve pretrained features. This form the base of the model. These are the output. Then add in custom layers. I add a global average pooling layer, a dense layer with ReLU activation, and a dropout and a final softmax to output layer to classify the images into the disease categories. These are the outputs. Then we compile the model. Then we train the model with the 20 epochs. For the fine-tuning purposes, we unfreeze the last 30 layers. Then we run the 15 epochs. In this, we can see the evaluation of the model with the validation accuracy and the validation loss. Then we can see the visualization of the training results. I plot training the validation accuracy and the loss curves to check the model learning and the detecting overfitting or the underfitting. These are the diagrams.
And as my part, I'm implementing a simple neural network, which is I'm using thick convolutional blocks, and I'm flattening the layer as well, and also I'm normalizing the input to the input pixel rate to 0 to 1 for better performance. And then I have a dense layer of the classification, which is a multi-class classification, and also I have a softmax layer as the output, which this softmax layer will use the probability distribution to identify the multi-class classification. And if I see the summary, if I compile and see the summary of the model, as you can see, there are total this much of trainable parameters, and this is the summary of the model. And I used 15 epochs to train the model using the given dataset, and each epoch you can see the training accuracy and also the validation accuracy is increasing while the loss of validation and training is reducing. And as the final epoch, we can get total of 94% of training accuracy with 0.1677 loss, and in the validation part we can get 0.90, which means 90% accuracy on the validation dataset, and also validation loss will be 0.3101. And if I plot these in a proper graph, as you can see, the training and validation accuracy is shown in this graph, and also the training and validation loss is shown in this graph. Usually the training accuracy and the loss is training accuracy is much higher than the validation accuracy, but as the end result, this is the output that I got from this model.
Hello everyone, my name is Karivasam MGPY and my IT number is IT220113998. So the model I developed is Deep Convolutional Neural Network, which is designed to automatically learn and extract visual features from plant leaf images. So this consists of 4 convolutional blocks which containing 2 convolutional layers with ReLU activation and batch normalization for stable learning and max pooling layers to reduce dimensionality while keeping important spatial information. So after these convolutional layers, the feature maps are flattened and pass through fully connected layers for classification. The final output layer uses softmax activation function to predict probabilities for each of the 38 plant classes. And here you can see the model summary. And the model was compiled using Adam Optimizer with learning rate of 0.001, and sparse categorical cross entropy as the loss function. And accuracy was used as the main performance metrics. To make training more efficient, I used two callback functions, the early stopping and model checkpoint. Early stopping is used to stop training if validation accuracy doesn't improve for 5 epochs, and model checkpoint uh, is used to save the best model in best DeepSeek NN k-rounds. And the model was trained by using 20 epochs on augmented images using rotational flips and zoom to improve generalization. So during this training, I monitored both accuracy and loss for training and validation dataset. Um, so this graphs shows the training progress. The training accuracy is steadily increased around 96%, while the validation accuracy followed closely about 95%. So loss values are decreased smoothly, as you can see, showing stable learning with no major overfitting. So when evaluating on validation dataset, the model has achieved around uh, achieved a validation accuracy of 94.97%, and the validation loss is 0.1776, indicating strong generalization across plant types.